Myself, Tamapian, studying in Shiventeshwar College of Engineering as CSCI. Today's topic is aggregate-oriented databases. Aggregate-oriented databases are designed to excel in managing vast amounts of data by optimizing for scalability and performance. These databases prioritize speed and flexibility, over strict adherence to traditional SQL-based relational models. The aggregate-oriented database is the NoSQL database, which does not support ACID transactions, and they sacrifice one of the ACID properties. Aggregate orientation operations are different compared to relational database operations. We can perform OLAP operations on the aggregate oriented database. Aggregate is a collection of data that interact as a unit. Moreover, these units of data are aggregates of data from the boundaries of the ACID operations. What are aggregate oriented databases? There are three. NoSQL approach, data modeling, scalability. Aggregate in a NoSQL approach, aggregate oriented databases utilize a NoSQL approach, departing from the rigid structure to traditional relational databases. In data modeling, data is organized into flexible nested data structures known as aggregates rather than being confined to tables and rows. In scalability, these databases are designed to scale horizontally, allowing them to handle growing data volumes and processing the demands. Key characteristics of aggregate oriented databases. First one is data modeling. In data modeling, aggregate-oriented databases use flexible schema-less data models that can adapt to changing requirements. Scalability. They are designed to scale out across multiple servers, handling high-volume data and traffic. In the performance, these aggregate databases prioritize speed and low latency for data retrieval and processing. Benefits of aggregate-oriented databases. First one is flexibility. Aggregate-oriented databases can easily accommodate changing data requirements without the need for complex schema migrations. In the high availability, they are uh, designed to be fault tolerant and maintain data availability even in the face of hardware failures. It is scalable because these databases can scale out to handle growing data volumes and processing demands. Uh, Aggregate-oriented databases offer fast data retrieval and processing times, making them suitable for real-time applications. Use cases for aggregate-oriented databases. E-commerce. Aggregate-oriented databases are well suited for managing product catalogs, shopping carts, and real-time recommendations. In the social media, they can handle high volume and velocity of social media data, including user profiles, posts, and interactions. Real-time analytics. These databases excel at processing and analyzing large streams of data for real-time decision making. In IoT and sensor data, aggregate-oriented databases are well equipped to handle the massive amounts of data generated by connecting devices. Designing data models for aggregate-oriented databases. Identify aggregates. Determine the logical units of data that should be treated as a whole, such as customer or an order. Define relationships. Establish how the various aggregates are connected and how they reference one another. Optimize for access patterns. Design the data model to align with the most query and access requirements. Querying and manipulating data in aggregate-oriented databases. Query languages. Aggregate-oriented databases often use domain-specific query languages like MongoDB query language or Cassandra's SQL. Data manipulation. These databases typically provide simple and efficient ways to create, read, update, delete data within aggregates. Analytical queries. Aggregate-oriented databases excel at running complex analytical queries on large datasets, enabling real-time insights. Consistency and durability in aggregate-oriented databases. Eventual consistency. Aggregate-oriented databases often prioritize availability and partition tolerance over strict consistency, following the principles of the CAP theorem. Data replication. These databases typically employ data replication techniques to ensure high availability and protect against data loss. Durability guarantees. Aggregate oriented databases provide various levels of durability guarantees and such as write head logging and atomic transactions. Scaling and sharding aggregate oriented databases. Horizontal scaling. Aggregate-oriented databases can scale out by adding more nodes to the cluster, allowing them to handle increasing data volumes. Sharding. These databases often employ sharding techniques to partition data across multiple nodes, improving query performance and load distribution. Load balancing. Aggregate-oriented databases utilize smart load balancing algorithms to ensure even distribution of data and processing tasks. Comparing aggregate-oriented databases to relational databases. First one is data modeling. Aggregate-oriented databases use flexible schemaless data models, while relational databases have rigid table-based structure. In the scalability, aggregate-oriented databases are designed for horizontal scaling, while relational databases typically scale vertically. Uh, Query language. Aggregate-oriented databases often use domain-specific, while relational databases rely on SQL. Consistency. Aggregate-oriented database prioritize availability and partition tolerance over strict consistency following the principles of CAP theorem. Thank you for watching my video. Please like, share and subscribe.